program manager. I was a principal engineer. Before that, I was a materials engineer. What's called the MMRTG program, multi-mission radioisotope thermoelectric generators. Don't worry, they won't be a quiz. That is one of them, and this is a model of one. This is the Perseverance rover, and the generator is the only power source on the on this rover and on the Curiosity rover. I worked on both of them in different roles. So it's been a very interesting project for me, and it's also cool to see something that I made with a Lego model. Just a little about me. I'm Natalie's dad. I've been with my current company since 2004. I've worked this program for most of that time, from 2004 to 2008 and 2014 through now. And my education is, I have a Bachelor of Science and a Master of Science in ceramic engineering from University of Missouri-Rolla, which is now Missouri University of Science and Technology. These are a few pictures of the generator. I had the opportunity with the Perseverance rover to support fueling of the generator. This generator converts heat into electricity, and the heat comes from a plutonium heat source, which complicates things. It's radioactive, and there are a lot of safety concerns with it. But I supported fueling at Idaho National Lab, testing mostly in Idaho, and the spacecraft integration. Since it's a radioactive device, it's actually the last thing that's added. There are special hatches on the spacecraft just to put the generator in. So, and I have three pictures of it. The generator is up in that little cage there, being hoisted up to level 7, which is right across there. And this is the generator after it landed. We're about 200 feet up there. If you ever have the opportunity, this is at Cape Canaveral Space Force Station down in Florida. But if you ever have the opportunity, the best view that I've ever seen is from these decks up here. The building is about 100 yards from the ocean, and you can see straight up and down the beach from that deck. I actually got there because I followed a group of people that I thought were going to the bathroom, and they went up instead of down. But it was a very interesting place to be. This third picture is after the rover was launched. It was lowered. It got to Mars. It was lowered on what's called a sky crane. The sky crane had cameras on it, so we got this view of the rover just before it touched down on Mars. My job on this has changed over the years. I started off as a materials engineer, and I was responsible primarily for the internals of the generator, the parts that convert heat into electricity, which is just, there are no moving parts in this generator. It's something that happens within special materials called thermoelectrics. And I was responsible for the production of those, the assembly of the internal, what we call the thermoelectric core, which does that energy conversion, and also this nice white paint job on it, which is a lot more complicated than a normal white paint job. There was a lot of work that went into that. As I progressed, I became more responsible for system level, meeting system level requirements. So there's a lot of testing, and there's actually a very long requirements document that we have to go through and verify that each generator meets every one of these and state how it's done. Every one of those, most of those are done by a test that has a report. And so a lot of my job is actually writing. Writing, reading, reviewing, editing, to make sure that the information gets across clearly. And if I write a report that verifies a requirement, I need to be certain that it conveys that the requirement is met. Everything here is also made by procedures. We have procedures for everything. Those have to be right. They have to be clear so that somebody reading them can understand what they need to do, so they can do it properly, and we can minimize mistakes. As program manager, now I'm kind of coordinating, I have a lot of engineers working for me, and I coordinate their work, make sure that they have the tools that they need to do their job. If something's getting in their way, I help to try to get it out of their way. And believe me, there are a lot of things that can get in the way, whether it's something, some part is, is stuck at this station that needs to move on, so I have to go and give somebody a kick, or things like that. But that's what I do a lot of the time now. It's been a really interesting project. It's a great source of pride for me to see these on Mars. This is the second one that I worked on that's on Mars. First one was on the Curiosity rover, which launched in 2011. And in that case, I was primarily responsible for the inside. In this case, I did a lot of the finishing, testing, requirements verification, and took it kind of over the finish line. Are there any questions about it? Yes, sir.
How long did it take to make the Perseverance rover?
It was somewhere around 5 to 7 years from the mission approval to launch. The Perseverance was based on the Curiosity rover, which is a very similar design. There were some significant changes because we learned some things on Curiosity. There are also different science instruments. So there are about 15 instruments here, all made and operated by different companies or different groups. So there's a lot that comes together. My part is, it's an important part. It's the only power source on there. So if this dies, the whole mission's over. But there were a lot of other things that had to come together. So it took quite a while. This generator was actually sat for about 3 or 4 years untouched, just because we got to a certain stage and then stopped, and then then picked it up again and finished it out. Yes.
How did you get started in this business?
In this case, well, so I went through school. I got my degrees. I had a couple of other jobs previously, and in this case, I stumbled into this job. I applied for a job on I think it was Monster or one of the big job boards, and this was the opportunity that came up. I got the job. I was hired for a different project that was canceled at the beginning of my 3rd week of work. So I had to find something else to do, and wound up on this, and I've been working on it most of the time since then. This was not really, I never really set out to get to this, but I followed the opportunities.
What are the most challenging aspects of this career?
This career, so this is a big space flight system, and what's challenging here is that there are so many different people involved, and everybody's very specialized. I can tell you anything you want to know about this generator. I can tell you a little bit about the wheels and like a couple of other parts, some about the batteries, but that's about it. And other people working on these, they don't know anything about the generator. So it's difficult to coordinate with everybody, make sure that somebody else doesn't make a decision that's going to cause problems with the generator that they think is going to be fine. It works for their hardware, but not for mine. So coordinating with all these groups. This is NASA. This is the Jet Propulsion Lab. Multiple other companies. So just keeping everything straight is difficult.
Is the rover made out of Lego?
No, this one is. That one is not. That was mostly aluminum and titanium. Yes.
What are the most rewarding aspects of this career?
Seeing my work on Mars and seeing it as a Lego set. That's pretty cool. I was working on the project for off and on for 15 years before I got to this point. I'd seen Curiosity, but I wasn't involved in the final stages of that. I was a junior level engineer, and coworkers kind of did this part of it for curiosity, so I wasn't as invested in it. This one, I stood there and watched the launch. I was there for 3 weeks before the launch, and so seeing it land and function properly was a real source of satisfaction for me.
Have any more questions? Anyone have any more? Do you get to interact with a lot of, like, for example, a lot of people from NASA then, as far as?
I do, yes. So right now I'm working mostly with, they're not officially part of NASA, but the Johns Hopkins Applied Physics Lab, which is they're putting together a mission called Dragonfly, which will be powered by one of these generators, it'll be slightly different, but that's they call it a rotorcraft. It's a helicopter about the size of this table that will land on Saturn's moon Titan, which has a very thick atmosphere and low gravity, so it's good for a helicopter flight.
Mhm.
And so that will sit on the surface and then make some scientific observations, and then fly to another location and sit in the location for a period of time and do science. So yeah, I'm dealing with some parts of NASA. There's what's called the Radioisotope Power Systems Program Office, the Applied Physics Lab, which is the mission team. I meet with them every 2 weeks or so. Just have a teleconference with them.
So do you, for your work, do you have to travel a lot, or?
At times I do. For the year or so leading up to this, I spent 2 months in Idaho, over a month in Florida. Before that, California for a week. I followed this generator around to 5 different states. And so it really depends on the stage of the program. Getting toward the end, yes, there's a lot of travel, and there's, in a lot of cases, I'm there for launch. I had no official responsibility, but I was just there as an advisor. And it was critical enough that, that the mission paid for me to be there just in case. And the only technical input I gave during that process was that I agreed that we should reboot the laptop. But in case of a problem, I was needed there.
Mhm. Very good.
Yes.
How long would you say it took you to make one rover?
Well, so I only built one part of the rover, and that takes about one generator takes about 3 years, start to finish. But the rover itself was more like 5 to 7 years with all the systems. And I think there were some systems that they put on there that may not have quite been ready, but they said, well, we'll give it a shot, put it on there, and hopefully it'll work.
All right, one more question we have time for. Reed?
How long does the flight take from Earth to Mars? How long does it take?
It is about 8 months. This launch, or 7 months. This launched on July 31st of 2020 and landed middle or late February of 2021. And there are other ways to get there. That's the shortest flight, because it has to be launched at a certain time so that the planets line up right. There are longer ways to get there, but that's the quickest launch window.
Very good. Well, thank you. Let's give our thanks to our